from the previously defined sets. So set जो है उनके कुछ elements हो सकते हैं. What could be the components of these tuples? A, they can be sets. Okay. B, they can be functional mapping between the sets that I am using, or they can be element of the sets. These are the things that can be there inside these tuples when I am representing the devices that I want to represent or devices that I am trying to define. So we'll be looking at the collection which composes the notation of or representation of a finite automata. So if I want to define a finite automata, I need to define these 5 components. The first thing is Q, second thing is sigma, third thing is delta, fourth thing is F, and the fifth thing is Q0. So I need to write it nicely. Some time because writing with this mouse is not that easy. Okay. So I need to have these all things defined for a device to be referred to as finite automata. So one finite automata, say M1, if I'm naming that device as M1, can be defined by defining these 5 components for the device. So M1 I can think of as a data structure which has all these 5 components in it, okay? Which is a tuple data structure, and this definition is 5 tuple in that sense. Okay, you all know what do you mean by tuple, I guess. So tuple is a data structure that houses different type of data. So Q is a set, sigma is a set, F is a set. As I told you, these 5 tuples can be either set, functions, or element. Okay, so Q, sigma, F, these all are sets. This delta is a function, and Q0 is an element from the set Q. Okay, so Q0 is an element from the set Q. Okay, now we'll understand what they are one after the other. So the thing called as Q is a finite set of states. Finite set of states. That is what this Q is. Okay. Then the next thing that we have to define is sigma. Okay. What is sigma? Sigma is also a state. Sigma is also a state. It is also a finite set of alphabet. It is called as finite set of alphabet. The third set that we have in the definition, the sequence in which we write it is different, but here I'm using a different sequence. I'm just listing out first all the sets. So the third set is this F set. F set, okay. Some books, if you refer to, they call this set as, or they denote this set as A. Okay, कोई बुक्स में इसी सेट को F सेट को A कहा जाता है. Why so? I'll just let you know. But फिलहाल consider that this is going to be, again, it is finite, but it is subset of set of states. Or in general, we say that F is a subset of Q. Okay. What it means, some of the states from Q will be there in F. Some of the states in Q will be there in F. We'll understand it properly later. At presently, just understand what these are. So these 3, Q, sigma, F, they are sets. Okay, out of them, Q is finite set, sigma is finite set. Okay, F is also a finite set. Since it is a subset of Q, Q अगर finite है तो उसका subset भी finite ही होगा. I hope you remember, you know what do you mean by a subset. Subset means जो ओरिजिनल सेट में एलिमेंट है उसमें से कुछ एलिमेंट कलेक्ट करके जो सेट बनाया जाता है, that is called as subset. So अगर ओरिजिनल सेट Q is finite, then उसका सबसेट जो f है वो भी finite होगा. That will also be a finite set. I hope this is clear to you. Now the next thing that we have in the definition is delta. Delta is actually defined as a functional mapping. Delta is defined as a functional mapping. So we have it to be defined as Q cross sigma mapped to Q. So I'll just tell you what this notation means. So Q cross sigma means what? Okay. So I'll go to previous slide. I'll add a page. So I did not define what is Q cross sigma. Suppose my Q set is like this. Okay. And suppose my sigma, so I'm using S symbol to indicate sigma क्योंकि मैं वो symbol type नहीं कर सकता. Just consider that I'm representing sigma. Okay, so S is a set with values 0 and 1. Okay, then the product set, which is referred to as Q cross sigma, is a collection where I select an element from this set and I select all the other elements from the other set and list them together. So if there are 3 elements here, if there are 3 elements here, 2 elements here, the product rule says that this product set will have 6 elements. Okay, so what they are, we'll just look at them. So it will be A, comma 0. Then I'll have second element as A, comma 1. Now third element as will be B, comma 0. Okay, then I'll have B, comma 1. Okay, then I'll have C, comma 0. Finally, I will have C, comma 1. Okay, so this is the product set. So this is called as the product of these two sets. Just remove this, write it over here. The product set has these 6 elements: 1, 2, 3, 4, 5, 6. What we did was we actually took this, created a pair, took this, created a pair, took this, created a pair, this, created a pair, this and this created a pair. So in all, we created 6 pairs. Okay, so this is what cross product means, and this is what Q cross sigma means. So cross product is also a set. Again, it is a set of tuples. Now, whenever I say cross sigma is mapped to Q, this indicates I'm actually creating a map or a function between. मैप को दूसरे लैंग्वेज में फंक्शन बोला जाता है, मैप बिटवीन Q cross X and the Q set. Q set is ABC. So what I'm trying to do is I'm trying to represent a mapping. So this particular thing, mapping, okay, will be represented as, so how this mapping will be represented as Q cross sigma map to Q. इसको एक नया नाम दिया जाएगा जिसको बोलोगे आप डेल्टा. Okay, I don't have that symbol with me, so I'll just draw that symbol, delta. Okay, so delta is name of this functional mapping Q cross sigma map to Q. Okay, how will it be defined? For instance, if I want to have a single element in this set, so this ultimately is going to be a set. Okay, and this set will have elements. The first element will be a tuple A comma say suppose 0, and I have say A. Okay, so this will be a single element, and I will have such multiple elements in this particular mapping. In this particular mapping, I can have multiple elements like this. What this mapping indicates? What this indicates is I take this pair A0 and I connect it to this A. अगर आप क्लोजली देखोगे तो ए क्या है, एक स्टेट है, जीरो क्या है, एक अल्फाबेट है. सो अल्फाबेट इज ऑलवेज यूजिंग विच यू कैन क्रिएट द इनपुट स्ट्रिंग फॉर द डिवाइस. अल्फाबेट्स यूज करके आप इनपुट स्ट्रिंग क्रिएट करते हो. यानी व्हाट आई एम ट्राइंग टू रिप्रेजेंट ओवर हियर इज, इफ आई वेर इन स्टेट ए and I were to see an input which is 0, I will be back in state A. So I will be in state A, I see an input 0, I will be connecting myself to state A. So ये जो ग्राफिकली हम लोग दिखा रहे थे, यही चीज को यहाँ पे आप टेक्सचुअली यूजिंग सेट थ्योरी रिप्रेजेंट कर रहे हो एज अ फंक्शनल मैपिंग. Q क्रॉस सिग्मा मैप टू Q. Q क्रॉस सिग्मा मैप टू Q का मतलब जो ग्राफिकली हम लोग इस चीज को ऐसे रिप्रेजेंट कर रहे हैं. नाउ फॉर इंस्टेंस से सपोज दिस इज कनेक्टेड or this is related using this function, then what you will write is, if I were in state A and I am supposed to see input 1, so this was input 0, and if I were to say input 1, I will be going to state B. I will be going to state B. That is what A on input 1 taking me to state B. So this is something that we visualize using a transition graph. And this is something that we create using the mathematical representation of the device. Okay, so we are capturing essentially the same information. We are capturing essentially the same information. I hope this particular thing that I discussed just now, which is called as a set, a tuple, and a mapping, is clear to you. Okay, so what we have as fourth element in this entire discussion of this entire definition of finite automata is Q, which is finite set of states, sigma, which is finite set of alphabets, delta, then F, which is subset of set of states, that is subset of Q. Okay. Finally, we have delta, which is a mapping between Q cross sigma and Q. So this arrow indicates a mapping. Cross product indicates that I am selecting a tuple, okay, or a couple, I should say. I am selecting one element from set Q, I am selecting another element, one element from sigma, and creating a joint representation. And that I am mapping with the set Q, every element in the set Q. Okay. Now, it is not just that for finite automata, this particular mapping is present. There is one more thing, and that is Q0. Now, what is this Q0? I told you that in the definition of these devices, we have certain things, few things are sets, few things are functional mappings, and few things are elements. Now, this Q0 is a special element from the set Q. Now, यहाँ पे ये जो notation है, ये sigma नहीं है, ये जो क्या बोलते हैं उसको, member of relationship होता है set में, वो है. Q is a member of capital Q. So Q0 is a member of capital Q. That means it's a specific state from capital Q, which is referred to as a start state. Start state. Okay. So now I'll just refine the definition and clearly state what it means. So finite automata is a pi-tuple abstract device which represents certain kinds of computations, which is defined as a tuple including Q, sigma, delta, F, and Q0, where Q is a finite set of states, sigma is finite set of alphabets, F is subset of states, which is subset of Q, delta is a mapping between Q cross sigma map to Q, which represents the transient behavior, okay, or the functional behavior of the device. Okay, that is why this functional mapping is also referred to as the transition function. Another name for this same function is state transition function. Okay, why you require to say state transition? Because transition function करता क्या है? स्टेट से एक स्टेट से दूसरी स्टेट में आपको लेके जाता है ऑन स्पेसिफिक इनपुट. सो नाउ व्हाट इज द कंपोनेंट ऑफ दिस पर्टिकुलर मैपिंग? ओके, एक साइड में एक टपल है, लेफ्ट साइड में एक टपल है. टपल का पहला कंपोनेंट क्या है? एक स्टेट है. दूसरा कंपोनेंट क्या है? एक इनपुट है. तो दिस इज माय इनपुट. Okay, and this is the current state or current computational state, I should say. This is my current state. This is the input that I am receiving. Okay, what this represents is my output state. So this represents my output state. Okay, so this is how these devices are working. If I am in a state and I see a particular input symbol, I decide to change my state to some other state, or I decide to remain in the same state. Now, if I decide to change my state in say QI state, if I am in QI state and I see an input A, suppose, then when I decide to change my state to QJ, this will be written, or this will be shown in graphically like this, and this will be shown mathematically as delta with input QI and A will result. So this is how it is indicated. This is a notation, vertical line and a dash. A single dash is there. I should just rub it off. Use a vertical line so that you also draw it correctly. So this is a vertical line and I have another horizontal line. This is a small line at the center. So this is a notation. This says that when I call delta function with Qi comma A, this is going to produce output as, this will produce output as Qj. That means it will change my state to Qj. So this is the transient behavior that this function delta captures. So delta में दो input है, current state, current input, और एक output है, next state, or the output state. So from input state I am moving to output state. From input state or current state, I should say current and next. That would be much better than saying output state. So current state से next state में मुझे delta function allow कर रहा है जाने के लिए. Now, if this transition is a self transition, that is, I'm not changing the state on a specific input, it will be denoted graphically like this. I will be in state Qi. On say input A, I am still remaining in state Qi. This is how I graphically show a self loop or a self jump, I should say. So from Qi, I am reaching Qi on input A. This is what it indicates. And using mathematical representation or set theory representation, I can say this to be, so if I was in Qi and I saw an input A, I still remain in Qi. Okay, so this is how you can represent transient behavior of your device. So finite automata is what? It is a 5-tuple device that has components referred to as Q, sigma, delta, F, Q0. Q is finite set of states. Okay? So it represents what all states of computation the given computation can be represented in or partitioned in. We saw yesterday that every state is representing certain pieces of string. So I can reach that state using those particular strings. And I cannot reach that state without that particular set of input. Okay? So partitions represent करता है क्यू. ये finite partition हो रहे हैं, इसीलिए ये डिवाइस को finite automata कहा जा रहा है. So my computation is considered to be having finite number of states during that computation. Hence it is referred to as a finite automata. Okay. So finite automata को finite automata क्यों कहा जाता है? Because it has finite set of states. Because of this property. That is, it has a finite set of states. Now, also understand that additional to finite number of states, automata, these kind of automata also